Hello everyone. So previously we had successfully designed permission and role management system. So today we are asked to design a multi-factor authentication system, also known as MFA, right? So yep, let's see what the question states here. Design a simple multi-factor authentication MFA system where a user first logs in with a password, yeah, then verifies a one-time password, nothing but we call it as OTP, right? So then verifies one-time password, nothing but OTP generated by the system within a short time window, all implemented in memory without any external database. As we are going with a single file CLI demo, we will be going with, or we'll be considering only in memory without any external database. Let's do one thing. Now, let's collect the functional as well as the non-functional requirements, and then we can move on with the further steps. The first functional requirement here is user can register with username and password. So this is one of the things. User should be able to register with username and password. On login, system verifies password first. On login, system has to verify or system verifies password first. Just remember this. If password is correct, then the system triggers OTP. If the password is correct, then what the system does? System triggers OTP, one time password. Yeah, generation. Next, user must validate OTP within a time window. Within a particular time window, user has to user has to validate OTP. Yep. So next, one last, this one functional requirement is access is granted. Access is granted only after both steps succeed. Only after both steps succeed. So that is the reason we call it as multi this one factor authentication, right? Let's move on with the non-functional requirements here. First one is fast in-memory simulation. Yeah, we are not dealing with any external database as we are going with a single file CLI demo. So we will be going with a in-memory simulation. Yeah. So next, secure OTP. Secure OTP in the sense fast in-memory simulation, no external database. Secure OTP in the sense we will be going with a random and time limited. We have to go with a random and a random OTP generation and time limited to the certain. We have to set the time window, right, for the 30 seconds or 1 minute, like that. Yeah. The third one is easy to extend for the SMS or email OTP in the future. So whatever the code that we write, it has to be uh, it has to make sure that it will be easy to extend for SMS or email OTP in the future. The final one here is thread safe for concurrent user validation. Thread safe for the concurrent user validation. So these are some of the non-functional requirements that they have given. So after discussing these two, mainly the question along with the functional as well as the non-functional requirements, I have chosen the algorithm that fits here, right? First thing, for this one authentication purpose, we'll be going with the authentication algorithm along with the SHA 256, nothing but hash based password verification. So authentication system we have already designed. Actually, we have successfully designed authentication system. The only thing along with the authentication system, we have to go with the OTP algorithm as well. So we have to generate random 6-digit or 4-digit or 6-digit OTP, right? So for the email as well as the password, for the email as well as the this thing SMS actually. Yep. So these two things we have to keep in mind. First thing, for the authentication algorithm, we'll be making use of SHA 256 hash based password verification, and for the OTP algorithm, we will generate or we'll go with random 6-digit numeric code with expiry timer. Yeah. The data structures we'll be making use of here as Python dictionaries. So we will be making use of the Python dictionaries, and the time complexity would lead to because of one, because per operation. So per operation in the sense the operations are register, verify as well as the OTP validate, right? Or OTP validation actually. These are the three operations. And what does the what will be the space complexity? Sorry, the space complexity would lead to because of n for n users, right? So for n users it would be because of n, right? So this is per operation because of one per operation. Don't get confused here, right? So this is fine, I believe. So this is about the algorithm choice. Authentication system uses SHA 256 hash based password verification. OTP algorithm uses random 6-digit numeric code with the expiry timer. Data structure will be making use of the Python dictionaries, and time complexity and the space complexity for the code that we'll be writing in the future would be big of 1 and big of n respectively. Now we are done with the algorithm choice actually. Yeah. what algorithm that we chose, we have already discussed that one, right? So this is fine. Now next, let's move on with the concurrency and the data model part. Yeah, concurrency will be handled using threading.log. So we have to import threading, right? So we will be going with the threading.log to maintain the concurrency, actually, to prevent the race conditions, right? So the next one is when multiple users try validating OTP simultaneously, right? So when multiple users try validating OTP simultaneously. So this is this one, concurrency handled using threading.log to prevent the race conditions when, sorry, this is not the second point. So this is same when multiple users try validating OTP simultaneously. Yep. So this is fine, I believe. Next, let's go with the data model here. So this is the data model. You just have a look into it. Take a look into it. I'll just pause the video and take a look into it, right? Or have a look into it. So here we'll be going with the password hash username, and then we'll be going with the password hash within the flower braces. So which consists of the OTP and the OTP expiry. Yeah, OTP and the OTP expiry. Set timer. We have to go with the expiry timer for the OTP. And OTP, it consists of the 4 or 6 digit random number, right? Every time user asks for it, this one submits for the OTP. So OTP random number has to get generated, either 4 number or 6 number. And OTP expiry, we have to set the timer. The OTP has to get expired within the particular time. So that for that we have to set the timer as well within the 30 seconds or within 1 minute. So based on the requirement, actually. Yep. So this is fine. Yep. So this is the data model we'll be going with, actually. Yeah. We have discussed the concurrency as well as the data model. So we have successfully discussed main two parts. One is concurrency in the data model, and along with it, we have discussed the this one algorithm choice as well. Yeah, now based on what we have discussed, I have designed an UML diagram. Just have a look into it. First, the main UML diagram, sorry, the main class here would be this one, authentication system or auth system. So this is the base class, actually. Yep, auth system. So this is going to be the base class, actually. We have to go with a multi-factor, this one, authentication system itself, right? So this is the base class. So under authentication system, we will be making use of three methods. One is register user, another one is login method, and the third method is verify OTP method. Yeah. And so this is the base class, and it consists of the three methods: register user, login, and verify OTP method. And second class we'll be going with this one. This is the subclass, and its name is user store, right? So it consists of only one parameter, namely this one, users, which is of the type dict, actually, which is directly dependent on the auth system class or the base class, actually. Just remember this. So just pause the video, have a look into it. The exact same thing will be articulating in the form of code. All the only changes will not be making any change. We'll be just adding logic to the methods and the parameters along with the classes that we have designed in the UML diagram. So we'll be making use of the same class, authentication system, auth system, and the user store class, which consists of three methods: register user, login, and verify OTP. So within these methods, actually, we will be implementing the logic. Actually, we'll be making use of same methods. Within the methods, we'll be implementing the logic, actually, and we'll be making use of certain parameters like users, which is of the type dict, actually, initialization part. Yep. So this we have to keep in mind. Just pause the video and have a look into it. So now we have discussed the main things. One is algorithm choice. The second one is this one. What do we call concurrency and the data model? Yeah. Based on that, we have successfully designed the UML diagram as well. So based on what we have discussed and the UML diagram, we can just write the code, right? So it's good time to write the code. Let's start writing the code. So let's start writing the code. The first thing is we have to import. So we have to hash the password, right? For that, I'll be making use of the hash lib, actually, right? Hash library, basically. This is fine. Next, we will be going with a random as well to generate the random password. This one OTP. Every time we have to generate the random numbers, right? Let's go with a 6 digit number, actually. Yeah, I'll be going with a random, and let me go with a threading as well. Yeah, for the concurrency part. Yep, so this is fine. First, as discussed, let's go with the main class or the base class, actually, auth system, right? So within the auth system class, first thing, let's move on with the initialization part. Yep, so let me go with the initialization part. So here, as discussed, let's go with the users and lock. Users, let me assign this one to the, or initialize this one to the dictionary, and lock, let me assign this one to the concurrency safety, this one, threading.lock actually. Yeah, I'll just go with users, dictionary, and also dot, I'll just go with the lock here. Yep, let me go with threading.lock actually. This has to show. Yep, let me give the parenthesis as well. Next, let's move on with the main part actually. There were three methods if I remember actually. Along with it, let's go with one more, nothing but the verify OTP as well, right? If you remember, uh, this one, register user, login, as well as the verify OTP. Three methods were there. Sorry, let's add one more method called hash password here, right? So for that, let's write the code first. I'll just go with hash password. So within this method, let's do one thing. I'll just take the parameter password. We need password, right, to hash basically. Yep. Let me return here. I'll just go with hash lib dot. Let me go with SHA-256 as discussed. Yeah. Let's just go with password. So we have to go with encode. Let me type this one as this is not showing. So this is fine. And let me make use of the hex digest here, right? Yep. So this is it for the hash password, this one method. Next, let's move on with the main method, register user. So we have to make sure that the user register himself with the hashed password. Registered users, already registered users, so will give the password, right? That password has to be hashed, right? So that one registers, basically this method register user, what it does, it registers the new user with hashed password in simple terms. Let's do that. I'll just go with def, sorry, register user. Let me go with register user, and let me go with username. Along with the username, let me go with password. Yep, so this is fine. Within the register user method, we have to make sure that the register, it registers new user with a hashed password, right? I'll just go with the lock first. So within this log, I'll just go with a simple if here. If username in, I'll just go with users actually. Let me go with the users. Let me return something here. I'll just go with return, user already exists. User already exists, right? So this is fine as well. Next, let's do one thing. I'll just go with users of username. Yep, so this is fine. Let me go with password hash. Password hash. Let's do one thing here. Let me go with the hash password of password, right? So I'll just go with hash password. This has to show. Yeah, hash password of. Let me pass the password here. This is fine. And also initially, let me set the OTP to none. Yep, OTP. Yeah, let me set this one to none. So this is fine. Then one more thing, we have to go with the OTP expiry as well, right? Initially, let's set that one to the 0. We have to set some timer. So initially, let me set this one to the 0 actually. Just go with expiry. Let me set this one to the 0. Yep, so this is fine, I believe. Next, what shall we do? This is fine. Next, let's do one thing. Let's return. What shall we return? I'll be making use of this string interpolation here. So let me do one thing. I'll just go with the user here. So let me call the username. We need the username here. So this is fine. Username registered successfully. So this will be relevant here. I'll just give registered. What happened here? Registered successfully, right? Yep. So this is fine. Yeah. Let me do one thing. Next, let's move on with a one more method named login. Yeah. I'll just go with login. Um, Let me go with username as well as the password. Yep. So within the login method, first thing we have to verify password and trigger the OTP generation, right? I'll just go with login actually. Yep. Sorry. Not with login actually. Yep. So this is fine. Def login. We have went with the two parameters. One is username and password. Now we have to verify the password and trigger the OTP generation. First thing, let me consider user here. Let me assign this one to the. We have to get the username actually. I'll just go with uh, users dot get of. Let me pass the username. Has to show. What happened here? Yep. So this one. Yeah. Next, what I'll do, I'll go with simple if condition. If not user, then within the if condition, let me return user not found. If not in the users, user is not found, right? So let me give some message here within the string user not found actually. I'll just go with not found. So this is fine. Next, let's go with a one more if condition here. If user, so this is fine. Let me go with password hash. Let me go with the password hash. Uh, if not equal to hash password actually. Let me go with hash password. Yeah, this one. And let me pass the password here, right? So let me pass the password here entirely. Yep. So this is fine. Mm, Next, let's return the invalid password. Yeah. So I'll just go with return invalid password. Yeah, invalid password. So this is fine. Let me come out of this one entirely. We are done with the login method actually. Yep. So we are not done with. Oh, we have to go with the OTP as well. So sorry. Let's do one thing. Let me assign the OTP to. Let's make use of the random integer here. I'll just go with random integer. So this has to show. Yep. So this is fine. I'll just go within one followed by the five zeros and this one 9 followed by the this one 6 times 9 you can say it, right? So this is fine. Yep. So next let me set the expiry as well. We should have the expiry this one time as well, right? I'll just go with time here plus 60. Not 60 actually. Let me go with the 10 basically. Yep. So this is just that OTP is valid only for the 10 seconds. You can just change this one to 30. You can just change this one to 60. It will be 30 seconds or the 60 seconds, right? So what happened here? Expiry. I have set this one to time, not time. Random. What's wrong here? Time is not defined. We have. Do we need to import time actually? I think we have to import time here. Haven't. Yep. So now the error has to be gone actually. 1 second. Yeah. Now this is fine. The next step would be after doing this, what we have to do. Let me set the user of OTP to the this one. Let me assign this one to the OTP. Yep. So this one. The next part is let me go with user of this one OTP expiry. I'll just go with the OTP expiry. So this is fine. Let me assign this one to the expiry. Yep. So this is also fine. Now let's do one thing. Let's print something. Yeah. Let's print something for the interactiveness. I'll just go with the print. So here the print, let me go with the string interpolation as well. So I'll just pass here system. So this is fine. OTP for this one. Yeah. Username actually. Yep. Username. Let me pass the OTP as well. Yep. So this is fine. Next, let me go with a valid 10 seconds actually. Yeah. Let me display this one. You can just change this one to whatever. If you are implementing seriously on something, so you can just change this one to the 30 seconds or this one 60 seconds based on your requirements, right? So this is fine. Next, let me return something password verified and OTP sent, both things, right? If everything goes well, I'll just go with password verified and OTP sent. So this is fine. Next, what we'll do, next let's move on with the third, sorry, the last method, nothing but the verify OTP. We have to verify the OTP, right? So for that one, let me write the one more method actually. I'll just go with verify this one, OTP. Let me do one thing along with the self. Let me go with username as well as the OTP. Yep, so this is fine. So within the verify OTP method, so basically it verifies the OTP with an expiry time, right? So I'll just go with lock. What we'll do first, let me assign user to this one. Get let me pass the username here, right? So this is fine. The next one, if not this one, user or user of OTP right, is actually none. If not user or user of OTP is none actually, then we have to return in that case OTP not generated. Please log in first. Right, something like that. I'll just go with OTP not generated. Please log in first. So let me return the same actually within the strings actually. OTP not generated. Then I'll just give here please log in first. Yep. So this is fine. Yeah, next what shall I do? Let me write one more if condition here. If time, I'll just go with the user of this one. OTP expiry, OTP expiry. Then what shall I do here? Let me return OTP expired, right? So I'll just give here return OTP expired. So this is fine. Yeah. Next, what we will do, OTP expired. So this is fine. Let me go with one more if condition here. If user of OTP, this is fine, is not equal to OTP, then we have to return invalid OTP, right? So the OTP that we received actually, if it is not equivalent to the same value that we enter, then in that case we have to return invalid OTP, right? So let me return here invalid OTP, right? So this is fine. Next, we are left with only one thing. All we have to do is, if everything goes right, so we have to access, I mean, we have to grant the access to the particular user, right, based on the username itself. So let me do one thing. I'll just go with return. So let me go with the make use of the string interpolation for the username actually. I'll just go with access granted to username. I'll just pass the username itself. Sorry, let me go with the username. Yep, so this is fine, I believe. Yep, so this is it for the verify OTP. Yep, so we are done with the coding part actually. We went with four methods. One is hash password, register user, login, as well as the verify OTP. So this is fine. Yep. So now we have discussed this one step by step. I don't think I have to explain this one again. Now let's do one thing. Let's get the example usage or the demo usage from the Google as usual. Just give me a second here. So let me do one thing. Let me paste it over here, right? So I'm calling here auth system, the main class actually here, class name auth system. So what we are doing here, we are going with a register user here, right? Register user. We are registering the user with the name Bharadwaj and this one password secure on to 3, right? So the login again, we are trying to log in with the Bharadwaj name and the password secure 1 to 3. This has to be correct actually. And next, user login successfully. Then here after user logs in successfully, then we are just going with a input enter received OTP actually, right? After user logs in successfully, then user has to receive the OTP. See here, simulate user enter and this one entering OTP, right? So verify OTP, we have to verify the OTP. So I'm calling the verify OTP here, right? So what is the output that we need to get here? Based on this, first user Bharadwaj registered successfully, right? So here user Bharadwaj this one registered successfully because we have registered with Bharadwaj and secure on 3 password, right? So next we are going with the login. So system OTP for the Bharadwaj. So some random number we have to get. System, we are going with the system OTP for the username. See here, this one line number 35, right? It is valid for 10 seconds, right? So system OTP for the Bharadwaj, some number actually valid 10 seconds, random number that's generated, 6-digit number actually. Next, password verified, OTP sent. So here we have given password verified, this one OTP sent, line number 36 actually. This is fine, I believe. Next, enter received OTP. In the case, whatever the OTP that's generated, we have to enter, else we will get the error, right? So finally, if we enter the correct OTP, what we have given here within the return, access granted to the particular user. In our case, we have went with Bharadwaj. The output that we need to get here is access granted to Bharadwaj, right? So let's check the same. Now, we have discussed the coding part, right? Different methods, initialization part, classes, everything. Yeah, and based on the UML diagram and other stuff that we had discussed, we have written the code. Now we have discussed the output part as well. It's good time to run the code actually. Let me copy the entire file here. I'll just give Control J. So let me give clear screen here. Python followed by the file name dot. Yeah, see here, user Bharadwaj, this one registered successfully. Now OTP for the Bharadwaj. So this one 8, this one, right? So valid for the 10 seconds. Let me give here OTP expiry. So let me give this one fast actually, right? So I'll just go with here. Let me, yep. So let me copy this one and let me paste it over here. Again, OTP expiry. What happened here? 1 second. 10 seconds is more than enough, man. Yeah, somewhere I have done something wrong. Line number 43, verify OTP. 1 second. 43, it's here itself actually. User OTP expiry. What did I do wrong here? 1 second. So we have to check the verify OTP, right? Oh yeah, we have went with the OTP underscore expiry, right? So let me give this one. Now this has to work correctly. So let me run this one again. So here now, let me copy this one and enter this one. Yeah, access granted. See, we have given only 10 seconds. See here, user Bharadwaj registered successfully. System OTP for the Bharadwaj. Random 6-digit number has been generated. It is valid only for the 10 seconds. Password verified here, right? So password is correct, right? So the same thing within the example. See here, Bharadwaj secure on T3. We have given the correct this one credentials for the login. Bharadwaj secure on T3. So this one OTP has been generated and password verified, OTP sent. OTP that we received here is 342848. I have successfully entered the OTP here. Again, I have copy pasted 342848, right? So I have entered the correct OTP. So access granted to Bharadwaj, right? So finally we have to get the this one. See here, access granted to, we have passed the username. We went to the string interpolation right here. Username, we have considered Bharadwaj, access granted to Bharadwaj. So we are getting the desired output. What if we give the wrong OTP? Actually, we'll get the error message, right? Let's check the same thing here. So let me give here 111 actually. Let me hit the enter. See here, in this case, if I give the wrong, if I enter the wrong OTP, in that case, we are getting invalid OTP, right? And it is valid only for the 10 seconds. We have set the time only for the 10 seconds. After 10 seconds also, you cannot enter, right? So that's also one thing. Yep. So we are getting the desired output based on the code that we have written. We have, we are getting the desired output, right? The output that we are getting is absolutely correct, right? So now we have discussed the coding part as well, and we have discussed the output part as well, and we are getting the desired output or the correct output as well. So now let's do one thing. Let's quickly discuss the limitations for the code that we have written. Yep. So let's quickly discuss the limitations for the code that we have written. So first thing here, OTP is printed to the console only. The first limitation, right? OTP is printed to the console, right? It is not secure. Ideally, it should be emailed or it should be sent via SMS, right? So this is one of the limitation. And the second one is no persistent storage. We are not going with any external database. Quite obviously, data will be lost on the restart, right? So this one we have to, this is one of the limitations, right? That we have to keep in mind. The third limitation here is OTP expiry check based on the system clock. right? So we are just going with a OTP expiry check based on the system clock. It is, if it is not synchronized, what if it is not synchronized for the distributed systems, right? So this is one of the limitations as well. The final limitation here, it lacks brute force protection for multiple failed OTP attempts. If we give the this one wrong OTP, then again the OTP has to be generated, or uh, we should be able to enter the correct numbers again, right? So it lacks brute force protection for multiple failed OTP attempts. So this is one of the limitations as well. These are some of the limitations for the code that we have written. Yeah. Next, let's move on with the final step. Nothing but let's discuss the alternative algorithms and the trade-offs. Right. First thing, the first algorithm that we can go with here is this one, TOTP. TOTP is nothing but, don't get confused here, it is nothing but time-based one-time password, right? So we call this one as RFC 6238, right? So what is the feature basically that we can implement here when we go with the TOTP actually? So we can go with a OTP generation, right? So we can just go with a time-based OTP generation. We'll be going with the OTP generation. The main trade-off is it requires clock synchronization, but it is more secure. But it is more secure, right? So we have to keep this in mind. Yep. So this is fine, I believe. The next one, external DB, usage of the external DB. We can just go with the Redis or the PostgreSQL for the cache, and this one, what we call PostgreSQL, we can just go with external DB as well. So the main thing here, the feature that we can implement here is storage actually. Yeah, we can just go with the storage. The main trade-off here is it adds the persistence, no doubt, but it increases the complexity. What it does, it increases the complexity, right? So this is one of the things. So the next one, we can just go with the JWT, the JSON Web Token plus HMAC tokens, right? So the main feature that we can implement here is security, right? The main feature that we can implement here is security, and the trade-off here is this one. It is stateless but more complex setup, right? More complex setup actually. Yeah. So this is one of the things. The final thing that we can go with, or the final alternative algo that we can go with, is implementing the async IO, or this one, concurrent dot futures, right? Concurrent dot futures, right? So we can just go with the async IO or concurrent dot futures. So the main thing it implements, or the feature that we can expect is concurrency. Yeah, the feature that we can, the future can, I mean, sorry, the feature that we can expect is concurrency, and the main trade-off would be, it is faster, no doubt, but it requires async refactor. It requires async refactor. So this one also we have to keep in mind. Yeah. So these are some of the alternative algorithms that we have to keep in mind. Yep. So these are some of the alternative algorithms and the trade-offs that we have to keep in mind. Now we have successfully designed this one, multi-factor authentication system. Yep. So we have designed multi-factor authentication system successfully, right? So now we are done with this part actually. So next what we will be doing, we will be designing password vault, right? So we will be designing password vault, right? So for now, I hope whatever we have discussed is completely clear along with the UML diagram and the coding part, right? So for now, this is it. Thanks for watching, guys.